Okay, so we are in this book right here, Generalized Linear Models with Examples in R, Chapter 3, and we're on question 3.5. Okay, so to gain experience reading QQ plots, we're going to use R to produce some QQ plots of data known to be generated randomly from a standard normal distribution using rnorm. So we're going to generate 10 plots based on 100 random numbers, again from rnorm. And then comment on using the QQ plots when n equals 100. And then repeat this for n equals 50, 20, 10. Okay, so this is pretty open-ended. So instead of producing 10 plots for 4 different sample sizes, I'm just going to write some code to produce one plot of each sample size, and then we can run the code several times and just look for some, look for some trends as we iterate on the code. So here I'm just producing a variable y with 100 values, and so I'm specifying n equals 100. And if I don't specify a mean or standard deviation, it assumes mean 0, standard deviation 1, which is a standard normal distribution. Now I'm also sorting these, and that will come into when we actually plot it. So this will generate random values, and by sorting them, we will get, starting with the smallest value, going up to the largest value of that particular random draw. Okay, so I have that for 100, 50, 20, 10. Okay, and so now I'm going to produce my plots, and so I'm going to put them in a 2x2 grid with that command there, and I'm going to plot the variable y 100 or 50 or 20 against the theoretical quantile. I don't know what you would call it, but the quantile array for the normal distribution, and I'm doing that with this. So I'm going from 0 up to 100%, 0% up to 100% with length of whatever my vector is. Okay, and similarly for y50, y20, da 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 da. So let's run the first set here. Okay, and so this is what we get. Okay. And let me just run it. So here's n equals 100, 50, 20, 10. And I'm just going to run a few here. Okay. Keep running it. You can see these. And there's a couple of trends that I tend to notice here. One is, as the size of n increases, right, as we go from 10 to 20 to 50 to 100, the range of the most extreme values for that draw gets wider, but that's to be expected, right? Because as we go, larger values, plus or minus, farther away from the mean, they get increasingly unlikely. So we need more draws to start to explore that part of the distribution on average. And the other thing that I believe that I am seeing is that as the sample size goes down, the average deviation from the perfect from the perfect quantile, the theoretical distribution using the quantile plot here, that the average deviation away from that gets larger. In this particular example with 10, looks like a particularly terrible draw, and so it looks like even the maximal distance is greater here than for the others, but I think that's just a fluke. So if we run this a few times, yeah. So anyway. So to kind of confirm that second idea here, that as n is getting smaller, the average there we go, the average distance between the data and the theoretical perfect normal distribution is getting larger. So to check this, I'm going to take the average of the absolute deviation from the data versus its corresponding quantile. Okay. So I'm going to run that. So we're getting the average absolute value deviations. And you notice that as I go from 100 to 10, we are consistently getting larger average deviations away from the theoretical, perfect normal distribution. Okay. I guess that is where I will stop.